Calculus BC, Lesson 1.2, Functions and Graphs. So values of one variable often depend on another. I'll give an example of that in a second. Call this a function. A function is something that's a rule that assigns a unique element from each member of a range, R, to each element in a domain. And people get hung up on definitions. Unfortunately, NBC Calculus will do that. But here's an example. I make a program that says, what day of the year is it? And right now it's about 175th day of the year. On day 175, the average temperature should be about 78 degrees Fahrenheit. And here's a counter example. If I tried to do the inverse of that, we've spent some time talking about inverses. If not, we will soon. It's 78 degrees out. What day of the year is it? And it is not a function because it would say, well, it could be the 175th day of the year, which is late June. That also happens in August, which is, I don't know, 215th day of the year or something. So it's not a function. It did not give us a unique element. You can do a vertical line test and look at something, and if you graph it and it's looking like this, you do the vertical line. No, this is not a function because it hits more than once. So functions are pretty important. We're trying to model the world. If I can model something and it gives me good data, then great, that's a function. If I model something like this and it doesn't give me good data, then not so good. How do we write function? And this just freaks people out. I think you guys can all handle it. F of x. A lot of people think, oh, that means f times x, a little dot in here, and f is something, and then the x, and it's not. F of x, meaning that it's a function of x, and we'll give you that. So, like, for example, what's the area of a circle? That's pi r squared, meaning that the area is a function of r. Greater r, greater area, and so on and so on. So what's the domain? Well, domain is the x, range is the y. Domain is what we put in, range is what we get out. Domain and range for the circle function, and I never write my domain right, but tough, is all reals. And that's just an r with the double thing here. So the bigger issue is, how do we write that in interval notation? So for the circle above, interval notation would be from negative infinity to positive infinity. Same for both. That's the way we write all reals. And get used to interval notation. We're going to use it a lot. How would you write this in interval notation? You'd say negative 3. This means no equals 2, 6. This means, in this case, less than or equal. Could, in other cases, be greater than or equal. So you have the bracket, we're going to call it. Probably the most important thing we'll discuss. Parentheses. Bracket. Other ways to do it would be what we call set notation. A set of x such that negative 3 is less than x is less than or equal to 6. Quite a few people have pointed out that A, I can't make a bracket to save my life, and B, that's really the same thing. Yeah, agreed. And we could also do number line, fill in the dot. Some people do this on the number line. Whatever. We'll be working off of interval notation. So identify the domain and range of the following graphs. Well, I've done all these in my calculator already. So 1 over x looks like this. So to find the domain, we'd have to say negative infinity all the way up to 0, but not including 0, and 0 to positive infinity. A lot of people look at that and say, wait a minute, isn't that everything? I say, nope, there's no 0, and the range is the exact same thing. For y equals square root of x, the graph looks something like this. And the domain actually includes 0 and goes to infinity. And the range includes 0 and also goes to infinity. And that's it. Two more. Again, I've graphed these before. You can just throw in your calculator and see what it looks like. This is half a circle, the upper half, the positive half a circle. And it goes from, I should not have put arrows in there. It goes from 2 inclusive to negative 2. And it goes up as high as 2. So the domain is negative 2 to 2. And we check if I put in 2 or negative 2, it works. And the range is 0 to 2. So a lot of people get bothered by domain and range. Well, how did you do that? I just read it off the graph. Y equals x to the 2/3. Fun little graph. Something like that. And we can put in anything for this. So the domain is all reals, but again, we write it as negative infinity to infinity. And the range is 0 inclusive to infinity. What's the definition of an even function? Even function, if we put in negative x, we get out what we would have gotten if we put x. So for example, x squared. Odd function, if we put in negative x, we get negative f of x. So for example, x to the 3rd. However, I don't like messing with the algebra for even and odd. I like just graphing it and looking at it. So even is reflecting across the y. When I do this with a sheet of paper, I say I could pick up the sheet of paper and just fold it right across the y-axis, and it would land right on top of itself. Odd has rotational symmetry, which means it rotates 180 degrees and it has to be about the origin. So again, if I had a sheet of paper, I would spin it 180, a half turn, and look at it and say, oh, it's exactly the same. That means it's an odd function. So are the following functions odd, even, or neither? If I were you, I'd pause this, try it, and see where it goes. I've already shown this one's even. Turns out this one, if you graph it, it's just one higher. And it still reflects nicely, so that's also even. Y equals x, people, I don't get it. What do you mean y equals x? Yeah, that's just 45 degree. Spin the page and it's odd. And y equals x plus 1 doesn't go through the origin, so I don't have to do anything. It's neither. And it's not even. Even doesn't have to go through the origin. Odd does. How about a piecewise? So break it down in chunks. Less than 0, we have negative x. And it does not include that. Negative x starts at the origin, goes up to the left. There's a dot at the origin because it does not include the origin. X squared includes here, so we'll make a smaller dot there, and goes up to 1. So it's going to do that. and it includes that too. Put a big dot here. These can be a little tricky to show. Do something like that. Make sure this one comes right off it so you can see. And then 1 from x is greater than 1. So again, we do this. Y equals 1. Off to the races. What about domain and range? Well, there's nothing I can't put in. So the domain again, negative infinity to infinity. Range gets all the way down to as low as 0. Inclusive. And then it goes up forever. Just reading it right off the graph. And an absolute value. Hopefully you remember this. Plus 3 brings us up 3. Minus 2 should go left, but it's messed up. It goes the other way. Nothing else changes. So we go up to the right, 45. Up to the left at a 45. So that's a graph. While I'm here, I'll do domain, all reals. I have a habit of writing all reals because it's easy. And the range starts at 3 and goes up to infinity. But what if we wanted to write it as a piecewise? Well, we'd have to break it into 2 pieces. And the first piece is this piece on the right. So that's, I believe, x plus 1. I'll have to check that in a second. And this is where x is, and we have an option here. We can say greater than or greater than equal to 2. So let's check that out. This is the point 2 comma 3. Plug in 2. 2 plus 1 is 3. Slope of 1. Check. That looks good. And again, I could have said just greater than 2. In this case, I said greater than or equal to. Now the other one is the slope of negative x, and it hits up high a bit. Since it's going up 1 over 1, it's 4, 5, so it looks like plus 5. And x is less than 2. So let's check it out. 2, negative 2 plus 5 is 3. Works out. So that's how we write a piecewise function. There's no rhyme or reason. We just kind of slap it up there and pray it works out. And you constantly check your work and make sure it's good. And a composite function. F of x is x minus 7. G of x is x squared. These are used a lot in calculus, so you better get good at them. Take g of x and shove it in. So f of g of x means where we have an x in f of x, leave a blank, and then plug in x squared. That's it. There's nothing else we can simplify here. And this is equivalent to what some people call fog, but is said the exact same way. F of g of x. It means take the g of x and stuff it into the f. Just for practice, I'm going to do this as a function. What's g of f of x? And we take f of x and stuff it in for g. So g is something squared. And f of x is x minus 7. So g of f of x equals x squared minus 14x plus 49. And then g of f of 2, which would have been a lot easier to do this by just putting the 2 in and cranking it out. But I wanted practice is 4 minus 14 times 2 plus 49 is 25. And we look at this, we could have just said, well, just 2 minus 7 is negative 5. Negative 5 squared is 25. Would have been a lot easier. So you can do it either way. I just wanted to practice doing the functions. That's it. Lots of math.